Thank you all for those of you who have tuned in. This is the second half of the question and answer period for session 15A for Goldschmidt 2020. I just wanted to say a couple words about this theme first, theme 15, which is called Geoscience and Society. And part of what we are trying to highlight here in this particular session and all the other sessions in this theme are the intersection between the scientific work we all do and the impacts on the general public. And those impacts are many and varied. Hopefully you've had a chance to view the presentations by our speakers. I've put a link in the chat for those of you who haven't found them yet on the Goldschmidt website. Gives you a link to each of the four speakers' presentations, as well as a brief introduction that I recorded several weeks ago. Unfortunately, one of our four presenters will not be able to participate this afternoon. That is Siggi Gislason from the University of Iceland. Many of you may know Siggi as the president of the European Association of Geochemistry. We let him off the hook because he's giving the plenary in a few hours from now, and he needs to have his sleep. But our other three presenters are here today to take your questions and answers. Those are, in no particular order, Don Swanson from the U.S. Geological Survey Hawaiian Volcano Observatory, Bridget Smith-Contour from the University of Hawaii, and Diego Melgar from the University of Oregon. And before we get into the Q&A with them, I also just wanted to make a plug for those of you who are interested to attend the other sessions, one session each day in 2 iterations, just like this one, of theme 15. There are a lot of very interesting topics, including climate and biodiversity, the origin of life, teaching and communicating science, and especially important in the present day, but always important, diversity and inclusion in geosciences. So please do come to all of those. I also wanted to make a special shout out to Adina Payton at UC Santa Cruz. Adina is a lead organizer for this theme and put in a lot of effort to make sure that this theme was as successful as possible. So thank you very much, Adina. So if you have questions, feel free to type them into the questions box that you'll see in your controls. And you can also raise your hand. If I see a question in the question box, I will try to get to it. I'm going to start off the conversation by seeding it with a couple of questions, but do feel free to add questions here. I also want to emphasize that there is a space on the Discord server. There's a whole channel for theme 15 where if a question comes up later, you'd like to address something perhaps longer to one of the speakers about their presentation or something along those lines, feel free to type it in on the Discord server, and I'll be monitoring. My co-convener Marie Edwards, who's also not here this evening, will also be monitoring, and we'll pass those questions on to the presenters to make sure that they have an opportunity to answer them. So I want to thank all of our presenters again for agreeing to participate in this session. And the focus is really about the way in which events that are unfolding during, sort of before, during, and after a geological geohazards event interface with society. And there's very, very many dimensions to that. Some of which are immediate, associated with hazards and risks. Some of them are less immediate, and hopefully we'll have time to explore some of that space in this coming sort of 45-minute session. So without further ado, I wanted to start out with the first question for everyone. Speakers, feel free to jump in whatever order you want. But I wanted to ask you a question about the sort of evolving role that you sense that perhaps the public do have now or could have in the future during the geohazards crisis. But this, I mean, not only being a consumer of information, which is the traditional role that the public plays, but also perhaps being involved in one way or another, participating in the dissemination of, interpretation of, the making of observations, all those kinds of aspects. So speakers, what do you think about that?
Go, Diego.
Sure, I'll go first. I think maybe one dimension is with sensors. The general public is usually very enthusiastic, early adopter of new technologies, and as we mentioned also in this morning's Q&A, there's been a revolution in sensors, and seismometers in particular are now dirt cheap, a couple dollars, $10, $20, $30. So we're in a place where we could conceivably see cities, every household have its own seismometer and contribute to an early warning system. How does that actually feed into an already built and existing system is a cool problem and an unsolved one, and definitely a challenge. But I see us living in a world 50 years from now where every single household is instrumented and can contribute, and there might be a future for other things like air quality and pollution measurements and things we haven't even really thought about. So I think they have a role there as actual providers of data.
I'll just jump in on that too. I think we should transition to the volcanic response though after me. Just a note about earthquake response though. There's a lot of, we talked about social media and the role of social media in the earlier session today, and we'll probably get to that some more. But I wanted to make a plug for the public's response to some really great tools provided by the USGS for earthquakes. There's a Did You Feel It website where if you're in an earthquake, you can immediately type in your zip code and provide some ground truth response to what kind of shaking you felt. And those are more qualitative than quantitative measurements of an earthquake, but they are indeed helpful, particularly in the aftermath of an event, to understand the source and the shaking. So there are tools like that that have been practiced and developed for years, and there's many others on the fly as we speak. But I would also say the public has a big role in just dominating social media in terms of what they observe in real time. And this is particularly relevant for volcanic eruptions. What I witnessed 200 miles away on the island of Oahu during the 2018 Kilauea eruption was phenomenal. How people were standing in their backyards and reporting about live fissures popping up before an actual scientist or some sort of military service or someone could actually come and respond to that threat. So I think I'll hand it off to Don to maybe speak more about that.
Okay. My expertise is with volcanoes, and a volcanic eruption is typically very hazardous. And so I think it's difficult to get the citizens into the area where an eruption is taking place. But you can observe the eruption from safe locations. And I can well imagine that there could be photo sites established where members of the public would take photographs at regular intervals. And this could become then a part of establishing the chronology and evolution of the eruption over time. I think another useful thing, it's hard to manage and pretty nebulous, is some sort of policing of social media. The scientists don't have time to do that and step in and make corrections, but members of the public who are knowledgeable and want to take part could help out a lot by correcting errors that are made on social media. I don't know. It's hard to see how you get the public close to an eruption, though. And I know that's what everybody wants to be able to do, or many people, but I just don't think that that's a feasible option. But I think this idea of establishing photo points is very viable.
Great. Well, those are interesting perspectives, and I think citizen science is a thing. It leveraging the power of the general populace when they are interested, when they can participate safely, is something that hopefully we continue to explore in our science moving forward into the future when it's safe. So another issue that was raised in essentially all of your presentations in one way or another, which were on a variety of topics, but a couple of them on volcanic hazards during specific eruptions and a couple on earthquakes or ground deformation during one case an eruption, another case large earthquake events, is the way in which scientists interact with sort of managers of civil society, civil defense organizations, the people that are land managers, etc., for dissemination of information. And one of the questions that came up to me as I was listening to all the presentations, thinking about all of the observations that were described are in places with fairly well-developed economies and very good infrastructure. And I'm wondering if you have any thoughts about what is similar or what is different communicating hazard and risk during a crisis or soon thereafter in less well-developed economies around the world, countries that maybe don't have the same level of connectivity for the populace, the same level of general education, and what are the special challenges there? Diego, you want to start?
Sure. I think that the connectivity is there in developing countries. It's just different than what we're used to thinking about in more developed nations. One way or another, in places like the U.S. and elsewhere, the USGS and other national agencies have a reputation that is good. Siggy in this morning was describing the reputation of the Icelandic Met Office. The same thing exists with GNS in New Zealand or JMA in Japan or many other agencies. So when people receive information from them, they trust it. They know that that's something that has value. And I think in developing nations, that's not always the case. Not for lack of trying from the national agencies, but just because the very fabric of society is different. So they might trust, for example, the village elder or the local leaders a lot more than they do some national agency, right? Which is far removed from their daily lives. And unless you have done that homework beforehand to make sure that you can translate to the local populations, who is your point of contact and how do you interact with them? Unless you know that beforehand, it's going to be very hard during a crisis to build those links. So I think it's different in that way. You have to learn to interact in a different way. And of course, the national agencies in those countries know and understand that. But it's a little more challenging perhaps because there's a larger plurality of actors that you have to learn to deal with.
Yeah, I think the USGS has a very successful program in helping during volcanic crises in such countries. It's called the Volcano Disaster Assistance Program, VDAP. And what happens is that a country in which there is a volcanic crisis building will make a request through the State Department, and VDAP will, or may not, but usually does respond to the request. And always when the VDAP team members go to the country, they work through the local scientific staff and community leaders. And always it is the local people who make statements. And that really shows how important what Diego was saying is. And I think I'm not a member of VDAP, so that I can praise it. Okay, well, I think it's worked very, very well and has received plaudits from many individuals around the world as how the scientific expertise of the USGS is being used in these countries.
Great. We have a couple of questions coming in now from the listening audience, and I wanted to ask a couple of those. Let me start off with the first one, and I'll focus it at you first, Bridget, but of course, all three of you feel free to chime in. This question asks, this is from Mark Norman in Australia, how do earth scientists who study longer-term challenges break through the focus of society on near-term issues like COVID and social justice?
That's a
Dean, I
heavy
guess
question.
Sorry, I apologize.
It's okay.
Yeah.
My internet connection seems to be slowing down, so give me a head cut if I need to. Yeah, I feel like major health pandemics obviously need to be prioritized over talking about earth science on a regular basis. However, when it's time to step up and there is a real crisis, then we have to put our best foot forward and be there and be prepared. You know, when we're teaching our courses during COVID-19, or if there's a, you know, strike for blacks, you know, demonstration happening, then there is a time to dial down the science and talk about real life issues. We're people and we can connect better with other people if we reveal our humanity rather than just blocking it off and being a scientist who just studies the books. I speak as a mother in that sense also, but I feel like there's a time and a place to really stress the significance of science. And we do our best that we can. However, it doesn't mean that we just stall until we have nothing to offer when it is our time to step up and show off. The USGS does a phenomenal job of being ready. And even though I know Dom had mentioned in the earlier session today how the Kilauea eruption was overwhelming. There was a huge response needed that while the scientific community was perhaps prepared for, no one can ever be quite prepared enough to jump in. But from the outside view, I thought they did a phenomenal job. And I would hope that academic institutions and those of us that work at constantly educating students can also have in the back of their mind a plan for what happens in your backyard. How do you respond when the time comes?
I mean, perhaps a corollary of this is to consider, as we've seen with COVID-19, at least in the United States, it has very different impacts depending on kind of what part of society you come from. And you know, I think it's also possible to conceive of geohazards playing the same role. Some members of society may be much greater impacted than others because of, you know, the group that they identify with or that they're associated with. And I mean, it feels like it's a challenge that I don't know how much we've collectively thought about that, but I'm wondering if in the course of the interactions that you've all had during the events that you've studied in the past, that you've noticed something along those lines and thought about how they may be addressed.
Well, I can talk about a little bit about the Mount St. Helens eruption in 1980. I took part in that, and different people were differently affected in great ways. The logging community, for example, had to close up shop for the summer, and whereas people living in towns and cities didn't. And so the impact on individuals was quite different. You know, much like with COVID, some people are living on farms and aren't as nearly as affected as those of us who live in cities. So yeah, I think a response to any crisis, I think, has to be tailored to the people that are being impacted by the crisis, and this impact can be different depending upon the individuals involved.
Did you want to add anything, Diego? Or Bridget, one of you? Yeah.
Go ahead, Diego.
Sure. So on the issue of how do you think about the long-term things when there's many pressing short-term things, I'll preface this by saying that social justice doesn't strike me as a short-term issue or a high-frequency issue because the Civil War ended in 1865. So it seems like it's a really long period issue that we're still trying to sort through. But I think the answer is scientists can't do it alone. And to think that we have that power is probably hubris. And the example here in Cascadia is that New Yorker article that came out in 2014 that won the Pulitzer Prize, the really big one. Everybody here in Oregon knows about that article. I don't think they know about any papers, any of the classic Cascadia papers that, the tree rings and the orphan tsunami. They don't know about that as much as they know about that one New Yorker article. And the only way those things happen is if we, come down from the ivory tower and talk to journalists and talk to other non-scientist people. So I don't know how we address century-long timescale issues of hazards, but I don't think we do it alone. That's not what we were trained for, so we need help there.
I completely, go ahead, Bridget.
No, please go ahead, Don.
Well, I completely agree with what Diego was saying. And I think that the best way to inform the public of hazards that may take place over a very long time span between the hazards is through examples. I think that we as scientists can talk a lot about data and measurements and so forth, but if you use examples, what happened at Mount St. Helens in 1980, and that might happen at Mount Hood in 2030 or something. I think that brings it home to the public. Examples of what has happened, how people have been impacted, really mean more than the data themselves.
I'll just jump in and from an earthquake hazard perspective as well. We talk about the big one in California a lot, and I don't mean to put this in the front mind of anyone who's living in California right now and looking out at the San Andreas. However, the numbers of people that will be impacted by what might be the next very big earthquake on the San Andreas will be on order with the numbers that are impacting people in California from COVID-19. So it's a big population of people that need to be thinking about these things. And while it may not be at the forefront of their mind, we can't stop ever stressing about preparing for these types of things.
Right.
And the USGS does a lot of great work on this effort, but the common scientists can be there to always remind people of that as well. Yeah, that's good.
Great. So there's one specific question about the VDAP. Let me just throw that in there, sort of a little bit out of order. Don, maybe you can answer this quickly. The question is that program a specialized division where scientists from all volcano observatories can contribute, or is it based out of a particular observatory? Do you know the answer to that?
Yeah, it's based out of the Cascades Volcano Observatory in Vancouver, Washington, and there are certain members of CVO that are assigned to the VDAP operation. But if VDAP needs people from other volcano observatories, there's no problem in getting them involved, and this happens frequently.
Got it. So we also have a question from Adina, which is talking about maybe asking you all to expand a little bit on the potential economic impacts of either past events or future events, and how planning for both mitigation strategies as well as better communication strategies might help sort of minimize those impacts. Thoughts?
Since I seem to go first when there's a void in the conversation, I'll do it again. I think one of the common misconceptions about earthquake early warning is that it's there to save lives. And while that is partially true, that one of its goals is to mitigate injuries and save lives, the truth of it is that earthquake early warning is expensive to build out and to operate. And it really only pays for itself if it's also connected to automated systems that can stop trains and stop power plant turbines. Because if you can do that, then the benefit of earthquake early warning is that your society bounces back from the earthquake maybe 2 days after the large earthquake as opposed to 2 months. And the economic value of that is huge. And we don't understand that very well, nor have we tried to measure it very well. But that is the real benefit of many of these early warning systems. It's not the romantic life safety aspect of it, but the longer term and more intangible ability of you to bounce back to where you were right before the crisis started, or the earthquake or the volcano struck.
Of course, in terms of volcano hazards, in a perfect world, people wouldn't live in areas where the hazards could affect them. but the world is very imperfect, and there's just no getting around that people are going to be impacted by eruptions. Governments realize that. And wouldn't it be nice if there could be a large kitty set aside to take care of people during times of crisis? That in general doesn't happen. So I think I guess I'm pretty pessimistic as to how society will handle the economic impacts of something like St. Helens or the 2018 eruption of Kilauea. I just think every time it happens, there is going to have to be some relearning of what's been forgotten from the past. So you caught me on a day when I'm pessimistic, but that's the way I feel.
I'll flip it a little bit for you, Don.
Okay.
So on an optimistic look, I don't have the numbers in front of me, but the engineering community has stepped up their game, and the ability to retrofit old buildings in earthquake-prone communities or build buildings that are safer and smarter, is the best way you can prepare. And Japan is a great example of this.
Yeah.
They have a community and economy that, an economy that will suffer from a big earthquake, but their buildings are pretty resilient, at least to large ground motions. We saw that in the 2011 Tohoku earthquake. Now, of course, that wasn't right underneath Tokyo, but they did well. They fared well, considering obviously the tsunami was a significant part of the catastrophe that occurred there. I can't speak about tsunami preparedness and economic value there, or economic preparedness, but from an earthquake sense, in a place where we can build in a smart way, then I think scientists are doing that. However, in economically disadvantaged places, that's not always the case. So I guess I flipped it back and I went pessimistic on your time.
Great. Well, thank you. Those are very insightful answers. I want to take us into a slightly different track now, into a topic that's near and dear to my heart, which has to do with big data, open science, open access, and all the kind of related issues. And in essence, I think something that the internet has given us over the last several decades, and social media over especially the last decade, is a public that has a much kind of greater appetite for and expectation of information flow in real time, and as well as scientists around the world that have knowledge, that want to be able to participate in sort of interpreting, analyzing, assessing, evaluating information as it's happening. And I'm wondering what you all envision about the possible modes for the future of enhancing information flow. Obviously, some information is proprietary or not necessarily proper to be shared, but a lot of it can be. And how do we sort of free open those pipelines to make it possible for more people to participate by having access to information and utilizing their expertise, so that we get the most sort of brain power during and soon after crises? Do you have thoughts about this?
I'll start, Diego. um, I don't have a lot to offer on this topic. However, good or bad, social media is doing this for us. In this day and age, it seems like it's sort of a race to see who can get something out there, and whether it's a competition among scientists or whether it's honest to goodness just wanting to communicate hazard knowledge to the public. I think it's both, actually. And that's a great thing. Now, of course, how the public ingests this and then perhaps relays it to the next person is where the finesse comes into play. But I feel like the ways that technology is allowing us to communicate so rapidly with each other is automatically thrusting us forward in this sense. When people respond to what they felt in an earthquake, it's usually that first on your phone or on a website with a reporter, rather than necessarily a scientist from Caltech reporting on the actual science behind what just happened. And that, as well as when they're trying to predict whether an event was a foreshock or whether it was a main shock. There's all kinds of jump starts at this. So I feel like we have the tools, we just have to be careful about how we do it.
Yeah, I mean, I think the tension with social media is that social media is the exact opposite of what science is supposed to be, because science is supposed to be deliberative, and you sit and you look at it and you let it stew, and then you decide that that's not the angle that should be pursued. Social media is not that. Social media is reactions and the right now. So I think there's, maybe in the future tweets are going to be citable, and you'll just have to say Melgar et al. 2019 F from a tweet that I put in up there. We definitely need to get with the times, because as you point out, can people consume this stuff? And as we also discussed this morning, there's some among us that are really prolific producers of social media, and I think we need more scientists like that. But there is a danger there, right, of the information not being necessarily as well curated or understood, and what gets delivered to the public being wrong, frankly. And maybe that's just something we need to live with, that it'll be wrong in the moment and it'll be corrected 15 minutes later. Yeah, I don't know. It is kind of an existential dilemma, I think, for many scientists to know how to use social media, not necessarily because we're socially inept, although we frequently are, but because it's the complete opposite of how you're trained to think about science. And that means we should probably be training people differently, perhaps. I don't know. I feel like I need 2 or 3 more beers before I know how to answer this question in a more illuminated way.
If I can just jump in real quick and add a side little story. There was a colleague of ours, works with the USGS, who is well known for his really smart approaches to looking at geodetic data. And when the 2018 Kilauea eruption occurred, there were many of us waiting to hear from him, or waiting to reach out to him, and he was MIA. He was not responsive, and we go to find out he stepped away from his role as a scientist primarily, full time at that moment, to actually handle a lot of the social media communication for the USGS. And so that was, I think, quite a service, actually. So if more people are able to do that, while you leave some of the science, the immediate science, to others, then that's a great. I think the USGS had a plan. They knew that this individual would be good at this, and he set everyone straight. So I'll let Don comment if he has anything.
Yeah, I think I know who that person is. So yeah, almost all the data that any scientists acquire is paid for by taxpayer money, and so if for no other reason, we should let data be released to the public, because we really owe it to them. They have paid for what we're obtaining. But as Diego was saying, the problem comes in with misinterpretations, and I don't know how to police that, to be honest with you. You get all this information out there, and there are probably always going to be people who want to be first, jump the gun and make interpretations, and early interpretations may or may not be correct, and I just don't know how to deal with that.
Can I add one more thing, Ken? The issue of policing and controlling social media came up also in the morning, and I don't think that's a battle we can win. We're not going to be able to control it. It's such an unstoppable force. And as with most discussions that become philosophical, it turns out that the answer to everything is always education. The only way we can guarantee that people consume information in the right way is by educating them better. And that is an issue that starts at the kindergarten level, right? So if in Oregon for the first time, earth science is going to be taught at the middle school and high school level. And I can't wait for undergrads to show up in the classroom and at least know what a tectonic plate is. Imagine that future, where people just are literate in these things. So I think social media is an unstoppable force, and I don't think we can control it. I think we can adapt to it the best we can.
Yeah, I mean, it's interesting. I think, in a way, in my opinion, social media is largely self-policing. It's not perfect, but the truth almost always comes out. It's a question of how many people absorb an alternate truth before real truth comes out. As a corollary to this question, I was thinking about this as you all were speaking. During that 2018 Kilauea crisis, I did an awful lot of TV news interviews, and each day, one of these professional journalists, so now we're talking about traditional media, not social media, would come up with the latest newfangled ridiculous scenario that they wanted to ask about. And they were all sort of exaggerations of what was happening on the ground in the absence of very much information, and sort of extrapolating that by maybe an order of magnitude to something that sounded like a much worse hazard than it really was. And so I'm wondering, to what extent we could develop a more educated sort of group of reporters, whether it can be done ahead of time or whether this all has to be done after the fact, but provide information about what the kind of the difference between very unusual, rare events that you probably don't have to mention to the general public because you're stirring up fears irrationally, versus the kind of more typical things that we all want to try and convey to the public as the very real risks and hazards of the circumstance as it's unfolding.
There's no doubt that there is a wide range of abilities and among different media people, and we can nurture the better of those, so much the better. But this is a cadre of people that is constantly changing, and so you need to keep on top of that too. But there is a problem, Ken, with focusing on only the more common kind of outcomes of crises. And St. Helens in 1980 is a good example, whereas we all thought that the eruptions were going to be mild, and instead it turned out to be quite catastrophic. And so I think it behooves us to work through qualified media to present the complete range of scenarios that might happen, and assigning, if not probabilities, at least general terms as to what may or may not happen. So the public is aware that something can be dire, even though it may be less likely than something could be mild.
I'll just pop in here. I need to give a shout out to my own university, University of Hawaii at Manoa. The Department of Communication, or the journalism majors, have to go through a final project before they graduate, which is traditionally a mock disaster event, where they interview scientists and they go through in real time how they would cover such an event, and then they have a few days to go back in the lab and fix up their footage and deliver it. And this is a requirement of the students that graduate from the University of Hawaii at Manoa. So each one of those journalists that we see on the TV or read their articles about, they all had to get a college degree. And so maybe it's our role to make some connection with those departments and stress how important these things are accurately covered and provide that kind of education.
Mhm.
Well, one of the things that I found so interesting about the presentations was the difference between sort of in situ real-time observation versus kind of predictive modeling and forecasting. This is something that really came out, Diego, in your presentation, that to some extent, especially for tsunami, but also for earthquakes, some of the potential hazards of one or another particular event can be kind of run through ahead of time by simulation, so that then after the fact you can compare it to that. And I'm wondering, does that kind of work or way of doing work play a role here, and should it be expanded to sort of other areas of the geosciences so that that same power could be applied?
Yeah, that really is value, and I think it plays into what Don was describing in terms of giving people scenarios and examples, and it brings me back to something I've seen again from GNS in New Zealand, where they had that the Kaikoura earthquake, which immediately triggered slow slip events all over. Everybody was freaking out because all hell was breaking loose, and it was right at the edge of our knowledge. Like, what does the slow slip event mean? Is it going to trigger a bigger event on the megathrust, which is already overdue for a big earthquake? And what they did is, instead of say yes, no, or maybe, they said, well, here's a really likely scenario, which is mild and probably nothing's going to happen. Here's a kind of less likely scenario, and here's a really catastrophic scenario. And all of these are possible. Some of them are less possible than others, but all of these are possible. And you can use these kinds of predictive models now to say not just that the catastrophic scenario is going to be bad, but you can maybe start to say, this is the kind of shaking we're going to see in different cities, in different parts of different cities. So we're really, we're still learning a lot, but we are quickly getting to a place where we can envision what tsunamis will look like in certain places, what shaking is going to look like in certain places, and translating that from, scientific geek speak of peak ground acceleration and that kind of stuff into you will be barely able to stand up for about 2 minutes. I think that really hits home. And I think that has a lot of value.
Other thoughts about that? Or we do have another question here on the question thing, which has to do with preparedness training through schools, for instance, providing of earthquake preparedness kits as an example here for schools in the Bay Area. And I'm just wondering, to what extent, I know these programs happen in different parts of the world, but to what extent we could leverage them to help develop a sort of more educated populace in various countries, by working directly with schools in the communities that would be impacted.
I'll take this one. So there is a world event called the Great Shakeout. We mentioned this in the earlier session. There are millions of participants each year. It is usually held the third Thursday in October. This year it's October 15th. And it is a joint venture between many organizations. Largely it is hosted by the US, but then outsourced to hundreds of countries. And it is a day to consider your preparation for earthquakes and to talk about earthquakes where you live, to talk about what you need in your earthquake kit, and to also do an earthquake drill, which is practicing the drop, cover, and hold on reaction to when an earthquake happens. Many people still think you're supposed to stand in the doorway of your building or your room, and things have changed. It's now you're supposed to drop to the floor and grab an object and cover your head or get under a table. So it's these kinds of activities that seem a little, I should say it, lame, maybe for the university types. These college students don't want to practice drop, cover, and hold on necessarily, but elementary and even high school students and teachers are really stepping it up to participate in these kinds of events. They don't always know about it though, so it's oftentimes necessary for the scientists or the leaders in the community to reach out to educational groups to let them know about this exercise. There's tons of media and multimedia and posters and flyers that you can You can distribute. There's even stickers you can get, and everybody can have one for their water bottle type of thing. So it's a big thing. And there's even one I've heard being generated or tested out for tsunami response. I don't know, Diego, are you familiar with that? It's a
I'm
USGS
not,
thing, I
no.
think.
I'm not.
Sorry, I didn't mean to put you on the spot. I've just heard little rumors about it. I don't think it's fully implemented, but it's kind of coming down the pipeline in terms of preparing for a tsunami type of event too. I think, yeah, Brian Shiro, I think at the USGS at HBO is working to spearhead some of that. So anyway, just putting that out there. But that's a big event, and everybody can participate, no cost.
Great. Well, we have reached the end of our time. I don't know, we might be able to go a minute or two over here, but I wanted to thank you all three for taking the time to participate and to share your thoughts in such a open and friendly manner with our audience, both this session and the prior session. I think it's really illuminating for people to not only see the science, but hear some of these sort of stories that are associated with the science, and understand how we all as researchers think about our impact from a societal perspective. So I just, in the last moment here, if any of you have anything you would like to say about your presentation, a minute or so of what you think, you hope people gain about it or learn from it, or anything else, I would just open the floor and let you say your thing. I guess Don, we'll start with you.
Well, something I said this morning, I think all of us agree with, is that education is so important for the public, and anything that you can tell the public to help them better understand what has happened and what will happen, in any way you can do that is really very beneficial. Scenarios, past events, field trips, show and tell in the observatory or the departments, any way that you can bring people with a hands-on experience, I think is very valuable.
Thank you. Diego?
Yeah, sure. I do think it's not, we have to come down from the ivory tower is what I'm hearing Don say. And I couldn't agree more. And more I realize that the planet is overpopulated and the world isn't perfect and people live and build where they shouldn't. And the only way to mitigate the risks associated with that is with applied science research. So I think what I've come to learn in my short career as faculty is that getting grants funded that are directly related to applied hazards research is harder than it is to fund a grant that has a basic science question underpinning it. And I would like us to move towards a model where that changes. It's not to say that the National Science Foundation should only fund the development of earthquake early warning technologies. They probably shouldn't, but they should fund at least some kind of sort of exploratory research into that kind of question. Because it's only going to get worse unless we force it to get better. It's not just going to magically get better.
Right.
And Bridget?
I think you're muted, Bridget, or maybe.
Yeah. Sorry, I would definitely agree with all that. I would also say, don't quit your day job, and in fact, prepare to expand your day job in the event of a major crisis, a major geologic event. On May 2nd, when this eruption in Kilauea really started, I was a earth scientist. I actually studied the San Andreas specifically, but and I was a resident of a state that was clearly about to embark on something very unusual. And 2 days later, on May 4th, when this larger than normal earthquake hit the Big Island associated with the eruption, I suddenly I suddenly had an opportunity to jump in and be a person who works with data, and I don't often do that. I often code and develop models, and so this was never something I had planned, and I really should have planned it much better. But it was an opportunity to jump in and try something new, and sometimes we're hesitant to do that, but if we have the right colleagues and collaborators and support, it can work out in a really great way. But I would just say that the only way that that was possible was because we had access to free data. And that's something that is really valuable to our community. So yeah, all the pieces got to fit, but if you can step up and try out something new, apply your skills, I think it's a great opportunity.
Great. Well, I want to take the opportunity to thank you all again and to thank Siggy in absentia. And for those of you who would like to go view the presentations again, they will be up at least all week, perhaps longer. So I encourage you to do that. And please, come back for the rest of Theme 15, the other sessions that will be happening one a day for the entire week. So from here in Hawaii, I want to say aloha to everyone. Have a nice afternoon, evening, morning, whatever it is in your time zone.
Aloha.
Mahalo, Ken.
Thank you, guys. That was great.
Okay.
I need
Thank
some
you.
sunscreen out here.